joining us. Today we have Dyann Daley, founder and CEO of Predict, Align, Prevent. Her session title is Place-Based Predictive Analytics for Child Maltreatment Prevention. Thank you, Dyann.
Hi, thank you for having me. First, I just wanted to tell you just a tiny bit about myself. I'm a physician. I'm an anesthesiologist and an associate professor of anesthesiology and pediatrics at University of Arkansas for Medical Sciences. And I'm also the founder and CEO of Predict, Align, Prevent, which is a nonprofit organization that's dedicated to the work that I'll describe today. So this is a picture of me in my natural environment in the operating room. So the reason that I got involved in child abuse prevention is that in the operating room, we see some of the most terrible outcomes that you can imagine from a variety of different causes of injury and illness. And for me, a child maltreatment fatality was the most impactful of any case that I've ever had. And it got me involved about 5 years ago in child abuse prevention. So what I've developed since then is a workflow that is really a continuous quality improvement cycle that is meant to figure out how do we prevent child abuse before a child shows up in the hospital or in the operating room with a serious or fatal injury. And so everything that I'm going to talk about is kind of built on that concept. And really all I'm going to talk about today is the predict phase. So there's a lot more to this work. But today we're limited on time, so we're just going to talk about the prediction part. So defining the problem, about 1,500 to about 3,000 children die in the United States because of child maltreatment every year. Most of these children, 75%, are age 0 to 3 years old, with the younger children having a higher risk. And something that the Presidential Commission to Eliminate Child Abuse and Neglect Fatalities found was that about half of the children that die due to child maltreatment are not known to child welfare services at the time of their death. Now, this is really important for place-based prediction of child maltreatment because currently, in most child welfare agencies, the thing that people use to begin the process of using AI to predict which child or which family is at the greatest risk for recurrence of child maltreatment or fatality from maltreatment is a call to child welfare. So if the children that are at greatest risk aren't known to child welfare, that means that that call is never made. So that process, which is very helpful in the context of intervention, is not there to identify the children that are at risk before they are harmed. So the workflow that we developed began with the idea that we know that children that have higher risk of child maltreatment and communities that have higher risk of child maltreatment are going to be more likely to have exposure to the population of adverse childhood experiences. Now, this is a really old study. About 20 years of research has gone into this. And essentially what it is that if a child is exposed to child abuse and neglect or household dysfunction in the form of mental illness, an incarcerated relative, domestic violence in the home, substance abuse in the home, or loss of a parent through divorce or death, that they're much more likely to go on to develop a whole host of social, educational, health problems, economic problems throughout their lifespan. And so one day when I was thinking about, well, how do we find these little kids that are at great risk for child maltreatment? I thought about, well, what if we look spatially to see where these adverse childhood experiences co-occur so that we can figure out if what's happening with the children in those areas. So that's how all of this was born. So the theory behind this type of modeling is that at a population level, people are having exposure to things like adverse childhood experiences, to enabling or criminogenic infrastructure, unmet critical needs and capabilities, unhealthy social norms and social isolation that lead to the neurodevelopmental, epigenetic, and behavioral adaptations that lead then to all of the outcomes that everybody's trying to prevent that are also risk factors for child maltreatment. So each one of these issues or exposure, adaptation, and outcomes, they don't exist in a vacuum. They all exist in the same places. And so this is really the foundation for figuring out where the risk is going to be the highest for child maltreatment, and also, therefore, for these outcomes in the future, for the point of prevention. So the idea of using spatial supervised machine learning for this really came from Joel Kaplan and Les Kennedy, who use risk terrain modeling to do something very similar. So the example that they used, and I use here to explain what this really is if you wanted to predict where you would find a child exhibiting the behavior of playing, where would you look? Now, obviously, you're going to look to a playground, but the question is why? So we're going to have at a playground infrastructure for play, some sort of gathering location for people that have needed resources like water fountains and bathrooms. You're going to have other kids there that are social influencers. You're going to have infrastructure for safety, which makes it more likely that a person will bring their child to this location, some form of transportation, and then also things like nice weather, daytime, the time of year. I want you to think of all of these things as features of the environment that increase the likelihood that you will find children exhibiting a particular behavior, in this case, playing. Now, I want to point out that I can't tell you which child you will find playing in this environment, just that you will find children playing in this environment. So this is a place-based approach, not a person-based approach. So the way that this works, and I'm going to show you examples from various cities, kind of all interspersed together, but the process is the same. So we take the location that has been designated or determined by the child welfare agency in that particular state. This is Richmond, Virginia. We put a lattice grid over the top of the study area. So it's an aerial grid. There is no, it does not conform to any political or census boundary. And we then look to see for screened in child maltreatment reports, which are the best predictor available of the risk of injury for a child in the future, or for child maltreatment fatality to occur in the future. We look at the count of these events at an address level and aggregate them up to the cell. We find statistically significant clusters and then begin to look at closeness tests for the different risk and protective factors that are known to be associated with child maltreatment in the literature. So all of the different factors come from the literature, and everything is also at an address level. So we're looking at Euclidean distance, nearest neighbor, and the aggregate to figure out which features to include in the modeling process. And it looks kind of like this. So the types of things that we're going to include as potential predictor variables are going to be factors that are related to community risks, so things like violent crimes, things related to potential protective features, so things like where are the police stations, where are fire stations, faith communities, where are services provided, and then also things like code violations, which can sometimes indicate blight or other issues in a community. Then we subject the final data sets to, or the feature sets, to 3 algorithms to create a stacked meta model. So it's a generalized linear model, a spatial Durbin, and a random forest. And then we include in all of these models the leave one group out cross-validation measure to attempt to improve generalizability of the model outputs at this, although we sacrifice some accuracy while we do that. Now, the reason that we do this is we want to come up with predictors that work in all of the neighborhoods of a city, not just the high minority and high poverty areas, because we know that the data will be skewed and biased in that direction. So that's part of it. And then we end up with a meta model whose output looks like this. So here you have the city of Little Rock, Arkansas, and the yellow squares are the grid cells where the child maltreatment risk is highest. The purple areas are areas where the child maltreatment risk is lowest, or it covers things like bodies of water or parks, places where people don't live. So what we've predicted here is the geography where the risk for child maltreatment is the highest. And then to validate it, we take the following year's child maltreatment data and overlay it on top. So what you see here is that each black dot represents a child maltreatment event and where it occurred spatially. So what we can see is that we can predict the majority of future child maltreatment cases in a fraction of the city's area. So the risk category 5, which is the yellow area, is the highest risk place, and it comprises about 10% of the geography and 15% of the total population. When we look at whether or not we can validate that the child maltreatment events do occur in these places, but part of the theory behind this is that the exposure to adverse childhood experiences and criminogenic infrastructure, for example, is increased in the highest risk places. So we would expect that the severity of outcomes would also be increased based on the risk designation of the area. So what we found in Richmond is that about 60% of child maltreatment events occurred in the highest risk areas. And so did child maltreatment fatalities and removals into foster care. So these are the three things that child welfare agencies are working to prevent. So if we can figure out where these things are most likely to occur in a fraction of the population, it makes it much more likely that we'll be able to place our prevention resources in the locations where they're likely to reach the people that need help the most, or where those resources are likely to do the most good. Another example from Little Rock, Arkansas, the majority of child maltreatment fatalities occurred in the top 2 risk categories, which is different from other cities. But I was able to look at all injury-related child fatalities, which can be increased based on exposure to adverse childhood experiences. And what we found was that 53% of all child fatalities that are preventable occurred in the highest risk areas for child maltreatment. And again, only 15% of the population lives in these areas. This is also the case with, if you look at violent crimes against elders or elder abuse, the vast majority of the elder abuse cases occurred in the highest risk places for child maltreatment. And the reason I looked at this is that the risk factors for elder abuse and child maltreatment, whether individual, perpetrator, or environmental, are very similar. And so what you see here is Little Rock and the risk map for child maltreatment. And in this case, the black dots represent elder abuse incidents. Usually I would go into a completely different aspect of what we do next when it comes to psychographic analysis or improving user experience. But because this is about predictive analytics, I thought I would just talk about some key insights from the work that we've done across different locations. So first, the designation of risk by grid cell is really different from what's available typically. Typically, people are looking at either census tracts or neighborhoods or zip codes, or sometimes even at a county level to assign risk to a particular area. And so what I wanted to show you here is that this is Little Rock, and this is the grid that's over the city. And you can see that the grid is much smaller than the typical unit of analysis that would be available to us. So for one example is when we look at ACEs data, the survey that's done nationally, the Burfus survey that looks at ACEs incidents in populations, they look at the 3-digit zip code as the smallest unit of analysis. So you can see, looking at this map, that if you were to do that, the entire study area would be covered by that 3-digit zip code. And if you're trying to allocate scarce prevention resources, it doesn't help at all to have information about an entire city or an entire county. So the added granularity really adds insight into where to place resources. Sometimes people will say, well, how is this any better than hotspot mapping, or if we go by neighborhood? And so I wanted to show you this comparison of risk by, or the number of maltreatment events by neighborhood in Washington, D.C. versus a meta model that designates risk in the way that we've discussed. So you can see that if you're using the grid cell designation for risk, you have a much more actionable data set, really, because you can figure out exactly what the locations are inside the high risk areas that are potential prevention targets or risk mitigation targets, or campaign targets, or whatever you're going to do for prevention in that area. So it definitely is an improvement over hotspot and other unit of analysis for risk designation. Another part of this process that we look at is, once you find the highest risk areas, what are the best locations for the implementation of some sort of prevention resource, whatever is appropriate for that community. So we map every single possible prevention resource that we can think of, and then we put a quarter-mile buffer around that, and then look at the mean predicted count of child maltreatment inside each circle. So what you see here on the right are purple and green and yellow dots. Only the yellow and light green circles are locations that are within walking distance of high risk areas. So this gives us an indication of exactly where to place prevention resources. And something else to note here is that sometimes people will say, well, we already know where all the problems are. Right? We don't need this information to tell us where the problems are. But if you go and talk to every single prevention location that is in the right area for prevention, they're not doing any prevention work. So there is a huge benefit to knowing specifically where to place resources. Now, another insight, so this is on a slightly different thought process, but often when people do this type of spatial modeling for risk of an issue like child maltreatment, they'll do a gap analysis that looks at the places that are that offer prevention services, or whatever the service is, and the level of risk surrounding that place. So if you look at a gap analysis for Washington, D.C., for example, looking at risk versus available prevention resources, you can see in the red areas on the left here that there are a lot of places that have fewer resources than they need for the risk that is present there. But it's really important to note here that this type of gap analysis does not tell you if the people that are living in the highest risk places are the ones that are receiving the resources. So what's more interesting to me and to my nonprofit is, how does the money flow to the people that need help? And are we actually delivering the necessary resources to the places where the people are that would benefit the most? And so this is a different way of looking at it, and it's actually data that's very hard to obtain, because it's not really part of the current reporting standards for philanthropists or government agencies that are typically the funders of programs. It's very hard to track where the money goes. And another thing I wanted to point out is, if you look at another ACEs related outcome that is related to child maltreatment are things like inattention or behavioral issues, conduct disorder. And so you would expect that in children that are in environments that promote these things, that they will be not doing as well in school, or that the schools will be poorly rated in comparison to environments where children are not experiencing this level of exposure. So in Little Rock, we looked at areas where the risk is high, so where the majority of the catchment area for an elementary school is high risk, to see, do the grades of the schools match up with the highest risk areas? And what's really interesting here is that the black areas are the areas where the risk is the highest, and then the gray areas where the risk is the lowest for child maltreatment. And the risk doesn't exactly line up with child maltreatment risk, nor does it with poverty. So if you look at the same type of map, only looking instead at the children in poverty, and this is from an organization called ACI in Little Rock, you can see that on the right here, you have areas in the north western part of the city where the school ratings are a D, but the poverty level is relatively low. Now, in those same areas, if you have high child maltreatment risk, you end up with you explaining why that school would be a D, but neither of these maps make sense of the southwestern districts in the city. And so what we've learned since then from, working on the ground is that there are communities in these areas where reporting is going to be lower because of immigrant status. And so I think it's really important to note that there isn't one unifier for all of these different concerns across space, but it's an important thing for us to look at because all of these problems are interrelated. The last thing I think that I wanted to mention about bias in the data is that it's not just bias in the data. It's also bias in community and professional perception of bias in the city or of risk in a city. So in all three of these cities, I've had extensive conversations with community leaders and business leaders, government leaders, and everyone everywhere is always shocked that there is risk on the other side of the barrier that separates the good part of town from the part of town where all those problems happen, right? So in Richmond, it's a river. In Little Rock, there's a freeway that was intentionally placed to separate the African-American community from the white community. And in Washington, D.C., there's also a river. So people will assign the idea that risk is present only in the area on the other side of this either artificial or built barrier. But the truth is that risk occurs on both sides of the barrier. And when you start talking with protective locations that are on the other side, they're often surprised that they are part of the discussion because they don't consider themselves or their organization or the faith community is the example that always comes to my mind. They don't realize that they're in the middle of a high risk area. There was even one pastor I spoke with that said, "Are you sure you're calling the right place? Because that stuff happens on the other side of the freeway," which of course, as we know, is not true. So I think that it's interesting to see in resource allocation decisions, sometimes communities that are also high risk are not going to receive the benefit of prevention resources because they are on the wrong side of the barrier. So something also to keep in mind and has been very interesting to me. That's really all I was going to talk about today, just because I know we're short on time. So I'm going to get out of this screen and head over to questions. And I really welcome questions or comments, any ideas for improvement for any of this work, because my goal is to figure out how to prevent child abuse. And, we need all the help that we can get. It's a big problem. All right. This is my contact information if anyone wants to get in touch with me. And of course, it's also on my profile for this event. All right. Okay, so I see some questions here that I'm going to attempt to answer. So the first one is, I guess I'll start at the beginning, the first one. In addition to spatial models, have you looked to family history features or transgenerational trauma as clues for where to look for elevated abuse? So I would say there are models out there that are looking at this type of issue. So for example, I think the most established example would be the Allegheny Family Screening Tool. They take this sort of thing into account for individual families as part of their risk prediction. So looking to individual family history for this type of information is not something that we look at, but it is important to consider the built infrastructure and how intergenerational or transgenerational trauma has affected where people reside in a particular location. Even as far back as to redlining matters when it comes to predicting spatial risk. So next question from Jan J. What are the demographic characteristics of these high-risk areas? So if you look at the demographic characteristics, they're going to vary across study area or a city where we're working. So often in the part of the town where it's across the river where people think it's the bad part of town, usually that's going to be a minority population. But when you look at when you look at spatial risk and latent spatial risk for child maltreatment, you're going to have all demographics covered across the study area. That said, there are some places that are high minority and high poverty that our model does not account for completely. The model starts to break down in those areas because there are too many more reports than you would expect. But then that's something that we can use to determine who is overreporting child maltreatment. It looks like data clusters geographically, even if not by zip code. Does it? And if so, why? Yes, it does cluster geographically. Child maltreatment does. And what the hypothesis behind my work is that features of the environment enable behaviors and encourage certain types of problems, like the exposure part that I told you about, that then cause these things to cluster in space. And I think that I'm about out of time, and I'm the person in the way of happy hour. So I guess I'll stop there unless there's something else that you would like for me to do.
No, thank you so much, Dr. Daley. It was a fascinating discussion, and probably just my limited awareness, but the first time I've seen predictive analytics on this type of a topic. So thank you for your time. I know that there are a couple of other questions that are out there. I'd encourage you to reach out to Dr. Daley directly or to move the conversation to our Slack channel, which is also a possibility. But thank you to everyone who joined us, and look forward to seeing you